All right, and we are live. So, hello everybody. Happy Thursday. So, Christopher, good to see you. Jay, good to see you too. Thank you all for joining me. I'm gonna go ahead and start with the most important part this evening, which is I made a pregame a little bit before the stream here. I had like half of a drink left in one of my really nice bottles, and I've been given marching orders by my wife that it's time for me to thin the herd and empty out some of my half-finished whiskey bottles that are lying around. So I drank a little bit of Old Elk, but I'm gonna pour for myself this evening. I've got a tiny bit of this left. This is Noah's Mill. So this is actually fairly high in alcohol concentration. Yeah, 57.15% alcohol by volume. I'm going to go ahead and pour this out and drink some of this because it's Thursday night, and that's what we do around here. So this is made by the Willet Reserve. So I actually drank on Tuesday night, I think, some of the Willet Reserve rye. The same distillery makes Noah's Mill. These bottles run about, I don't know, $59. They also make Rowan's Creek, which has a little bit less alcohol, but these are exceptionally sweet tasting bourbons, so they're pretty nice. So I'm gonna go and pour a little bit of that out. Probably got a little bit more, enough for another drink if I really want one. So I'll set that down. Go ahead. Yep, definitely has a very sweet nose. So that's like pure caramel and vanilla. So it's like the candy shop. Very tasty. It's one of my favorites, and it is deceptively for how much alcohol it has. It is deceptively non-alcoholic tasting. So you gotta be a little careful with that one. You can end up doing some damage if you're not paying attention. So, in terms of our stream tonight, what we're gonna try to accomplish. So we've spent a bunch of time in the past couple streams dealing with this. I'm just gonna be blunt for a second. We've been dealing with a whole bunch of really crappy stuff that the ASP.NET Core identity layer does. The scaffolding system for producing this identity and access layer stuff this is where I'm going to be crude. It is complete well, okay, you know what? I'm not going to be crude. I'm trying not to swear on streams and on videos, but it's complete garbage. So I decided that I wanted to try something different, and I wanted to go ahead and try to implement my own identity store using Akka.NET and event sourcing, and using some Blazor UI components to go ahead and actually handle all the login and authentication, because that ugly UI we had at the end of the last stream, that didn't even work, by the way. The identity scaffolding still didn't work, even after all that work we went through to try to get it all up and running. I decided I'd rather take my own stab at it to try to get it up and running here. That's what we're going to do. And I've got some sources up here for some examples of how other Blazor developers have been able to go ahead and do Blazor WebAssembly with an ASP.NET Core backend that allow them to go ahead and have users log in and out. Let's see, Christopher, mixing myself a limoncello today after having passed all of my exams. Well, congratulations. I know you've been doing finals for a little while. So glad to hear it. So, do you have another year of school to go, or is this, or are you basically done? Is this you're gonna get your degree after this? And while I wait for Christopher to reply back, I'm gonna go ahead and pull up a little code sample here. All right. So this code sample is from Jason Watmore, developer in Sydney, as he mentions here, and he went ahead and created a user registration and login example. Another year to go. Oh, hey, we've got a new follower. Depeshi, well, thank you very much. Appreciate the follow. So another year to go. So this will just be your last summer vacation before you're forced to endure the real world. Well, you know what? The real world isn't all that bad. I had considered once trying to go and get a PhD in computer science. My father has a PhD in theoretical chemistry, so he went through that whole process. And by and large, he told me after he got his PhD in computer science, after he got his PhD in theoretical chemistry, so in the 1970s, and he was doing his PhD, he was studying things like really early MRI technology. And he was doing that at the University of California, Los Angeles, where he did his PhD. And he basically told me, you know what, if you want to go into computer science, there's a lot of stuff happening in the private sector. You could probably go ahead and just get up and running pretty quick. But that being said, I've worked with a number of people who've gotten master's degrees and high level degrees in computer science. And I think if you're going into a field like distributed systems or machine learning or any of those other ones, I think having a high level degree in computer science is a good investment. I think generally speaking, having a high level degree is a good investment. So I once upon a time I considered doing the same thing myself, but ultimately I decided that right out of school I wanted to try to earn money right away. Unfortunately, I graduated in 2008, which was about the worst possible set of circumstances for new graduates ever. But you know what? Ultimately, it all worked out okay. All right, well, enough history. Let's go ahead and take a look at this. So, this Blazor WebAssembly example basically introduces a little Bootstrap UI, and this is all built into Blazor itself. And I've got examples of JSON source code up here. This is from about a year ago, some of this code. So last time it was updated was November 9th, 2020. But what I appreciate about the code that he wrote is that it basically can use local storage to kind of do everything locally if you want, or you can go ahead and use an HTTP service behind the scenes here to talk to a web API to go ahead and allow users to log in, log out, and all that sort of stuff. So what I would like to go ahead and do today is I'd like to go ahead and basically kind of ape what he's done here and build a little web API that's going to allow users to log in and out of drawtogether.net. And we'll go ahead and use Akka.net behind the scenes to event source all the different little state changes you need to build a user account. So I thought this might be a good opportunity to do a little bit of Blazor work. I absolutely loathe and hate the default scaffolded identity stuff that Visual Studio and Rider introduce. I think it is very overwrought for what we need. And plus, I've spent a lot of time recently on Twitter and elsewhere talking a bit about event sourcing, and I thought this would be a good opportunity to actually get into doing some of that. So where I'm going to start is by actually subclassing the user store class, or more accurately, if we take a look at Microsoft's documentation on how to do, I'm going to go ahead and drop a link to this chat actually. This is Microsoft's documentation on how to write a custom identity system. Specifically, this is all about the storage end of things. By default, all of Microsoft's identity stuff is built on top of Entity Framework. I personally think Entity Framework, and specifically Entity Framework migrations, are one of the biggest foot guns in the entire .NET universe. So I strenuously want to try avoiding it. So I'm going to attempt to build a version of this identity store down here that's going to go ahead and use Akka.persistence to go ahead and allow us to gradually event source all the changes to a user's profile, to their claims that they might have, and also will go ahead and provide sort of, let's say, an audit trail of everything that's ever been done to go ahead and change that user's state. So in order to do this, we basically need to be able to go ahead and build a interface that is going to go ahead and implement oh, hey, Rook, good job with the workshop this week. Any chance of doing a design patterns one? So doing an Akka.net design patterns one? You know, one of the other ones that I've kicked around with some of the other members of the Petabridge team is doing an Akka streams one, actually, doing some patterns around using Akka streams to try to solve commonly recurring software problems. We've considered doing that, but I haven't actually sat down and fleshed out any of the content yet. By the way, I should go ahead and grab a link to our recording from that stream. So I'm going to go ahead and let's see, I've got Petabridge's YouTube channel right here. Let me go ahead and copy the link address. Okay, I just dropped the link to our basic webinar that we did on yesterday morning, which is all about Akka.cluster, which is something that we're going to be introducing into this code sample too. It was really good. Well, thanks, Rook. I really appreciate that. And yeah, we talked a lot about how to, like, showing when and how to use Akka.cluster. I did that whole webinar primarily because we had a couple of questions in our Akka.net Gitter chat that made me think that basically a lot of things that seem like they should be spelled out in our documentation, some of our examples weren't as clear as they should have been. So I wanted a chance to go ahead and kind of in a long form presentation address that. And we had something like 40 questions I had to answer at the very end. In terms of all the, that's like the last half hour of that entire video. It's just me knocking out questions at the end of the presentation. So what I'd like to go ahead and do tonight, actually, I guess I already have this pulled up. Well, I'd like to go ahead and do tonight, let's take a look at this. Okay, user store base might be the class. Let me take a look at that. User store base. Woof. That is a lot of crap. All right. Well, we'll do the best we can. I want to go ahead and try to build an Akadata implementation of this class. But, good lord. That is an awful lot of junk. All right. So the entity framework version of this uses this identity user string. Okay. All right. Well, maybe we'll see if we can get away with that. Maybe I can get away with that. Okay. Well, let's go ahead and try to implement this first. So I'm going to go ahead and do, this is our Akka.net's draw together code. In fact, let me grab a link to this repository for anyone who wants to follow along. This is all open source. It's on the Petabridge GitHub organization. And if you want to go ahead and clone this, Christopher has already sent like, I don't know, 5, 6 pull requests and has made a lot of contributions. If anyone else wants to go ahead and report an issue or add a suggestion or just clone the source and try to run it themselves, they can. In fact, one thing I should do, since Christopher's here, is Christopher, we actually significantly improved, believe it or not, the total end-to-end performance of draw together on our last stream. And it was through something really subtle. Let me go ahead and comment this out. That's kind of a work in progress here. Let me go ahead and fire this up real fast. All right. Just so everyone can kind of also see what we're working on too. Okie dokie. Well, looks like I broke the UI again here, which we did last time too. That's okay. Let me go ahead and stash changes inside GitHub. Move that over here. All right. Whoops. Okay, there we go. That's good to go now. I'm going to go ahead and switch back. Let me go ahead and stop the build here. Get rid of that. Let me go ahead and switch back to our development branch. And then we'll try running this again. Builds exceeded with warnings. Well, thank you, JetBrains. All right. There we go. All right, so Christopher, prepare to be amazed. Look at how smooth this is by comparison to what we had before. So this is going really smooth. And then if I go ahead and change colors and cursor size, this is really smooth too. And I can go ahead and change this even more. Let's go ahead and do that. Nice green color here. And you can go ahead and see all the different little graphs that we're rendering. So the changes that we did last time around definitely helped when we were working on making it so we only did partial rendering and updates. That definitely helped. But the really big performance improvement actually came from a totally unrelated structural change that we made to the project on Tuesday, which was simply getting rid of the drawtogether.ui.client project, the separate WebAssembly solution, and moving everything inside the same ASP.NET application. We aren't totally sure why that impacted the performance so significantly, but a lot of the rendering latency that we were running into when we were trying to go ahead and do these complex drawings after a period of time, all of that just went away as soon as we basically merged the two projects together. So I don't know why that improved the performance of things. I don't think anyone else who was on our stream on Tuesday does either. But the results speak for themselves. It is very snappy by comparison now, compared to how it was before. So, yeah, who knows, right? Could be any number of things. I'll go ahead and reload here. I can keep drawing over it. Still looks pretty good. I can go ahead and also do this. I'll do a second concurrent drawing session just to kind of illustrate this for people who are maybe attending for the first time. Let me go ahead, change the cursor size and the color for the second user, and check that out. And you can see this got rendered over here as well. So yeah, very cool. I can go ahead and add that. I can go over here and I can draw on there, and that'll show up as well. So there is a little bit of latency end to end, looks like, between when a drawing is on a stroke is added to one client versus when it's rendered on another. So that could just be a function of, let's say, the server trying to dispatch those updates to both clients there. It could be that. Could also actually potentially be a browser-based issue for rendering it, because everything that's being served on screen for this client right here, all this rendering, this is all being done. Oh, actually, you know what? All that rendering, yeah, that's right. I have to basically release the brush stroke in order for that to show up on there. Okay, so maybe we're basically drawing on here and it doesn't get rendered until I let go. So maybe that's something we actually need to go ahead and work on, is we should start piping some of those changes while they're being made in both locations here. So that's another thing for us to work on potentially. But the latency looks really great. And yeah, serving it all over a single port seems to work really well. Go ahead and reload that. All right. So I'll go ahead and shut that down for now. So if I go back to my branch, which I call authorization anon, this is like my third attempt at doing this. Let's go ahead and grab that. Okay, so I was going to go into the identity area. And I have my little identity actor here. Let's go ahead and implement my user store. And we'll go ahead and do, sure, a DP anonymous user. That looks all right. Now, what methods do I need to implement? Dispose. Well, isn't that charming? Dispose, get user ID async, get username async, set username async, create async, update async, delete async, find by ID, find by name. Okie dokie. Well, that certainly seems charming. So, what I don't really like very much is I actually don't like how, like, if I have the DT anonymous user object, I should already know what the user's name is, because that's actually one of the properties here. In fact, let me go ahead and let me move this to, let me move this, I guess, with some file. Yeah, let's do that. Sure. So I take a look at my, let's say, DT anonymous user. If we go ahead and try to inspect some of the properties here, you know, the user already has a username. They have a normalized username and email, normalized email, and all this stuff. So if I'm running around, let's say, trying to identify, you know, who a user is or whatever, that should already be defined in that object. So why I would have a whole separate method for doing that is somewhat mystifying to me. That kind of seems like a leaky abstraction to some extent. But is what it is, I suppose. Okay. So get username async. Set username async. Get normalized username, blah, blah, blah. Okay, well, we'll go ahead and do what we can to try to support that. Now, what are some of the other, let me close that down. What are some of the other optional interfaces we're supposed to implement? iUser rule store, claim store, password store, email store, blah, 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 blah. Okay. Well, why don't we go ahead and just start with something really simple, which is we can randomize our user identities and just retrieve those backwards and forwards without actually needing to go and implement, let's say, the iUser role store and all that stuff. So this is all supposed to be somewhat optional anyway. We'll see if the sign-in manager, which is the next thing we have to go and implement, will work with any of this. It probably won't, but let's give it a try anyway. Okay, so dispose. I'm just going to turn that into a no op. I'm going to go ahead and pass in here. We're going to go ahead and TD, well, not TDD, but kind of mock this just like that. Identity actor root. This actor is going to function as an aggregate root for the entire identity system. I'm going to add some remarks. In a clustered environment, this will probably be shard region. In a local environment, this will be a parent actor in the child per entity pattern. Now, these are both comments in a clustered environment. This means that we're probably going to distribute these entity actors across multiple nodes. In a local environment, we're going to go ahead and just use what's called the child per entity pattern, which is a very common type of pattern that we use even internally inside Akka.net in a ton of places. So that's going to go ahead and kind of function as our backing store for a lot of this identity stuff. Now, let's see. Create user async. Okie doke. Well, I wonder if I can do this. I've got my DT anonymous user. I wonder if I can go ahead and declare this as a record. Now, inheritance may not allow me to do that. Let's see. Click or press Alt Enter. Oh, it'll let me roll back the changes. But looks like it won't let me do that. That's okay. Okay. That is fine. So what we'll go ahead and do here is let me take a look at our NuGet packages. Right now we have Akka.net 1.420 installed. So we should probably update that. Let me go ahead and take a look at the file system. How will you do persistent storage for this? I'm going to use Akka.persistence, which is pluggable. My Akka version, let's bump that up to 421. Let's go ahead and bump up Akka Bootstrap to 0.53. And then Akka.persistence extras. I actually don't know why we have that. That's probably copy and paste from another solution. Yeah, I guess it is. Oh yeah, this is from one of our other projects, that's why. Okay. So we're going to go ahead and if I go here, edit. I guess I got to go back to solution actually. We'll go to edit. Project file. Ooh, no, this should be Akka version. You know what else I'll go ahead and do? I'm going to go ahead and just bring in Akka.cluster sharding because that will automatically retrieve all the other packages I need. Go ahead and build this. Yeah, you're definitely going to learn a lot about Akka.net for sure. Starting. All right, let me go ahead and build that. Let me go ahead and build that real fast. So Akka.persistence is what we're going to go ahead and use next. This is intended to be a component, add a using directive. So there's probably some using directives that I'm missing in my imports.razor right now. That's probably why that's growling at me. Oh yeah, I remember doing this in our last stream actually. If I take a look at our authorization 3 pull request where I did all this, 89 files, yuck. Let me go ahead and search for imports. Wow. Imports, let's see this HTML. Ah, this is what I need to make that work. That's probably why the UI didn't render when I tried running it on this branch versus the development one. All right, so let me go ahead and commit that. Fixed off components rendering. Go ahead and add that. Wants me to do this again. So that's for GPG signing, which is a best practice if you're doing a lot of work on GitHub. You should always GPG sign your commits that helps people verify basically who actually made those changes. We do that because at our company, we've got a lot of public source code we work on for big companies, some of whom are publicly traded. We want to go ahead and make sure that all of our code that we commit can all be traced back to us in all of our projects. Okay. So next, we have to go ahead and make this I think it's a receive persistent actor. Yeah, there we go. All right. Okay, I need to go ahead and import that. And then I've got one abstract property I need to go ahead and override. The persistence ID. So what we're going to go ahead and do is I'm actually going to go ahead and kind of overload this property. String user ID get. I'm going to change this to user ID. Yeah. All right. This should still be persistent ID. And we'll go ahead and just have this return user ID. So the user's ID will be their unique user's ID. What is this barking at still? Okay, let's try that again. There we go. Everyone's happy now. Great. What data store are you going to use for this project? So Akada persistence is pretty flexible. And that's one of the things I'm going to go ahead and work on tonight is I'm going to go ahead and define a protocol for being able to make these changes to this user. We're going to try to start with totally anonymous users is kind of what I want to begin with. But we do need to have some place for kind of reading and writing that. The default data store that we're going to use for Akada persistence is going to be the in-memory data store. That way you don't need a database to go and spin this up. But that data store will only work so long as you're running inside a single process. Once you start spanning the system across multiple processes, which is what you need in order to actually put this on the internet, when we're going to be using Akka.cluster for some of that, we can either use Akka.distributed data, which is a in-memory replication system, which can also be made persistent. That's probably not a great fit for what we're going to do here. I'm probably going to go ahead and use something like Azure Table Storage instead. The reason being is that most of this data for managing a user's identity is fairly low impact. So you don't need something like SQL Server, which allows us to use a lot of indexing for doing projections and all that sort of stuff. That's kind of not really necessary for this project. And then on top of that, it's very easy to go ahead and locally emulate Azure Table Storage using a Docker container that the Azure organization ships called Azurite. In fact, let me see if I can go ahead and pull that up real fast. We use this inside SDK bin and a couple of other projects. Get rid of that. Yeah, here we go. Pull this up here, and I'll go ahead and drop a link to this in chat. So Azurite is a really low impact way of being able to go ahead and run. It's an emulator for the Windows Azure storage system that runs inside a Docker container. So you can actually run Azurite using something like docker.net inside our unit tests or integration tests if you want. So we do that quite a bit inside SDK bin. Some of the things we have to do inside SDK bin, which is it's kind of like NuGet meets the App Store. Some of the things we have to do in there include testing things like users uploading logos or actually people pushing NuGet packages and that type of stuff. We use Azurite as part of our integration testing for all that in order to make sure that code works for every single release that we do. So Azurite's pretty handy from that point of view. So I'm probably going to use Azure Table Storage. I could also get away with using, let's say, Redis or SQL or MySQL or Postgres if I wanted to. We have pretty up-to-date Akka persistence plugins for all those data stores. We also have some Akka persistence plugins for things like MongoDB, Event Store, and I believe there's some floating around for things like Google Bigtable, stuff like that. All right. So this is kind of the basis of our little persistent actor here. Next, I need to go ahead and define some protocols. Let's see. We'll go ahead and call this our identity protocol, public static class. Now, this protocol class this protocol class is static, not going to be used for anything. We're going to go ahead and stick all of the different members that can be used for manipulating a user's identity are all going to be inside here. So I'm also going to define an interface, public, what the heck? I did not mean to do that. Public interface I with, let's see, I user identity. And this is going to go ahead and have a string ID. Whoops. Let's go ahead and do that. So this I user identity, or actually I should say I with user identity, is going to be used to go ahead and make sure that all the messages that pertain to this protocol all have a user identity defined. Let's go ahead and do user ID. And then let me take a look at this DT anonymous user type right here. All right. Let's go ahead and do F12. I'm going to go ahead and create 2 windows here. I'm going to get a little bit of my screen real estate back. All right, so what properties do we have? We have an ID. This should be a string. We have a username, a normalized username, an email, normalized email, email confirm, password hash, security stamp. I don't know what that is. Concurrency stamp, random value that must change whatever user's persisted to the store. Okay, well, we can certainly do that. Phone number confirmed, 2-factor enabled, blah, 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 blah. Okay, all right. Well, these are all things we can do. So the first thing I'm going to go ahead and define, if I go over to my protocol, we're going to do a little bit of domain-driven design here. First thing I'm going to go ahead and define, we're going to do public record user info. And we're going to go ahead and define, as part of this record, string user ID. Be the first thing we do. And this will be part of the I. Well, actually, no, we won't do that just yet. We'll do a user ID. Actually, you know what? Yeah, I'll do string user ID. Public user ID. We'll go ahead and make this field. Oh, gotta define a type for it. So here's something with working with record types, by the way, in C#. So we're actually using a protocol really similar to this inside SDK bin. This property, let's see, I guess I need to go ahead and define a constructor. There we go. Basically, this property is read-only, and this property has to be specified in this user info object. Otherwise, you can't actually initialize our record type here. That's going to be a bit of a problem. So that always has to be defined. I think I set this project so you can't actually define nulls. Let me take a look. Looks like I haven't done that. Let me just take a look at directory build.props. Let me give this a try. Nullable. This is another nice thing about Rider, by the way. Rider has IntelliSense for all these properties in your CS project, whereas I don't believe Visual Studio does that. So that's very nice to have. Okay, there we go. So compiler's not complaining at me. That's a good sign so far. Let's go ahead and do string username, string email. In fact, I'm going to make all of these optional. And they're all going to default to null. Now you might be asking, what is it I'm about to try to accomplish here? Annotations for nullable reference type should only be used on code within a nullable section. Okay, you got it, Buster. So we're going to go ahead. Basically, what we're kind of creating here is a poor man's discriminated union is what we're building, which is a very common thing in functional programming. But in, C#, we have to kind of get a little bit more creative. So F# programmers kind of eat this stuff for breakfast, but not us. We've got to go ahead and kind of work a little bit harder at it. Password hash gets or sets salted hash, blah, 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 blah. We probably don't need any of that garbage just yet. Yeah. You know what? I'm pretty cool with just sticking with some of the simple stuff. Let's go ahead and do email confirm. That's good enough for now. Let's go ahead and do, let's see, I guess that's optional there. I don't really feel like locking out users. Christopher, I just looked at the current dev branch and it indeed looks like other collaborators only get updated when they themselves move the drawing on the board. Might be an error, the change added. I will check this out. You know, what it looks like to me is basically those sets of changes don't get pushed out to the socket necessarily. Although, no, maybe not. But that's something that we do need to fix. We do need to patch that. That way that real-time drawing comes in. You don't want to have to wait till someone releases their mouse in order to do that. I think I'm just going to go ahead and stop here in terms of all the different properties that we can set. So this is going to go ahead and create a user info property that we can use to change a user's name, email address, or changing their confirmed email. I can go ahead and add all these other properties here if I want. I'm just not really going to bother with it because I don't think they're needed. So that's what we're going to go ahead and stick with for now. Next, I'm going to go ahead and create public sealed class updates user. And this class is going to go ahead and take, if I define the properties here, I'm going to go ahead and give this I with the user identity. Update user is going to go ahead and take a user info record, updated info. Go ahead and do a little getter on that. Pass this in through the constructor. And then I have to go and implement this property. And I can go ahead and do that by doing updated info. Everyone's happy. All right, so this message type creates or updates user properties. So this is going to go ahead and give us a little bit of the ability to go ahead and create or update information about a particular user. So that'll be helpful. Next, I'm going to go ahead and take a look at my Akka user store. So what other things do we need to implement here? We probably need to implement some message types for this. So I'm going to go ahead and implement a message type that's going to go ahead and specify all the getters. So I'm going to go ahead and say, you know what? I'm going to go ahead and do public sealed class get user info. And I'm just going to go ahead and pass in this property. So this type should return if I go ahead and do C, this should be a user info object. One thing I will also do is I'm going to go ahead and do a special case right here. I should probably do it after this user info declaration. Public static read only user info no user. It means this user does not exist yet. And that's going to be a new user info and the user ID will be string.empty. Voila. So this will go ahead and be a special case that indicates that this user is found. I'll also go ahead and add an extension method here. Let's see. Let's see. Nobody. This user info. You can do all these things inside a static class. Define extension methods, all this good stuff. User. And I'll go ahead and do return user equals no user. I can get away with that because record types basically use equality by value by default. So if someone took this no user object and modified some of the properties using the with syntax, then this comparison will return false. But if it returns true, it means that this is still the same object or an equivalent object where string.empty was used as the user identity. So that should all be good to go. I'm not going to make that private because I don't see any value in doing that. Okay. Get user info. Let me go ahead and move the Akka user store over to here. Entity actor. Get normalized username, set username, create async, update async, delete. Okay. Deleting a user is something that we have not added support for yet. And we don't have find by name just yet. So we should probably add one of those as well. Okay, find by name. All right. We can add support for that too. So with user identity. So I'll add another interface. With username only. Username. Get. And I'll go ahead and add public sealed class. Get user by name. With username only. We don't know the user's identity, presumably, in this case, when we're doing this. So we have to have a secondary way of looking that up. Okay. That looks all right. Last thing we want to go ahead and add is a way to delete a user. So one way we can go ahead and do this is I can go ahead and create an event called delete user. So why don't I go ahead and do that? I could theoretically change update user to also perform a delete if I wanted to, but you know what? This might be more fun. Delete user. Okay. All right, there we go. That should be all set. In fact, I could theoretically define these as records, and there might be some benefits to doing that, but I'm good leaving that as is. Let me go ahead and commit that. Defined identity messaging protocol. Let me go ahead and add that. Move that over here. Now we need to go ahead and actually handle that protocol inside one of our actors. So this identity actor, let me find it. Here you are. Let me go ahead and move I guess the protocol could stay in this class. That's fine, actually. So I'm going to go ahead and create a private user info. And user info is actually going to start off with, guess what? It's going to be no user. That's where we're going to start. So what I'm going to go ahead and do next is I need to go ahead and create a couple of behaviors to actually go ahead and build up this user state. So first thing I'm going to go ahead and do is I'm going to go ahead and add support for command. And this command will be, in fact, you know what? I am actually going to go ahead and move this to its own file just to make things a little clean. Do that. Okay. And then that way I can do this using static identity protocol. Yep. Okie dokie. And so if I go ahead and move my identity protocol over here, I can go ahead and do, okay. Command update user. User update. So here's what I'm going to do. I'm going to go ahead and call persist. This is going to save this object. This command to our database. I'm going to go ahead and say, okay, we'll go ahead and save our user update here. And this actor, by the way, can't process any other instructions until this persist operation completes. So this is theoretically, it's non-blocking, meaning it doesn't block a thread. So we're not like suspending thread execution. But what this does is it causes the actor internally to switch its behavior to basically a buffering state. And it's going to buffer any other in-flight messages it receives until this one completes. So that's what we're going to do here. So we're actually going to go and save this event as is to disk. Or, excuse me, to an in-memory data store by default. Now, I could, in theory here, go ahead and customize the serialization to use something else, but by default, we're just going to use JSON.NET. And that should actually be good enough for now. For a real production version of this, I'd probably want to change using protocol buffers. That gives me a lot more control over versioning. It compresses a lot better, but most importantly, it basically makes the system more robust. So that's probably something I would do. Here's what I'm going to do here. I'm going to go ahead and do my, user info. Actually, first thing I want to go ahead and compute is basically what the I should really compute the set of changes that we're going to go ahead and apply. So let me go ahead and figure that out based on what's null, what isn't. So I'm going to go ahead and say, actually, you know, maybe I should create a user changed event. Let me go ahead and define one of those. Public sealed class user changed event. And then I'll go ahead and do a with user identity message string. We'll go ahead and say log change. In fact, you know what? I'll just make this a record. That should be easy. Okay. Here's what we go ahead and do. I gotta make that all Pascal case for a file like this. There we go. Right, so here's what I'm gonna do here. I'm gonna go ahead and take this update user command. I'm gonna add a little method. Detected user changed event. Let's see. Actually, diff user changed. I'm gonna go ahead. Actually, I can make this static if I really want to. Go ahead and do private static. And I'll go ahead and return a user changed event. And I'll go ahead and start with a user info. Start. I'll go ahead and do. In fact, you know what? I'm also going to add a Boolean. Okay. So we'll go ahead and do user event. We'll go ahead and also do user info. Like that. Do a little tuple here. And then I'll go ahead and do start. And then I'll go ahead and do user changed. Okay. There we go. Let me go ahead and grab some real estate here. So I'm going to go ahead and do is say, okay, I've got to go and evaluate all the properties that can change. So I'm going to go ahead and do, let's see, var. I'll go ahead and do, let's see, updated properties string. Go ahead and add a reference there. All right. All right, let's go ahead and do a switch on the user changed event. Let's see. Actually, I guess a switch probably won't really help here. All right. If changed. Oh, whoops. I'm passing in the wrong value. My bad. Wrong type. This should be a user update. Okay. Change dot. Let's see. Where are my other properties? Did those not get passed along? Because of how I defined it? Maybe not. Well, looks like maybe they didn't. Okay. Well, that's kind of a bummer. These other properties should be defined on there. One own exposing API. I don't know what the point of that was. Change dot. Okay, well that sucks. All right, fine. Public string username get init. Public string email get init. Public bool. It's email confirmed get init. That init keyword is basically what allows the record behavior, sort of the immutable copying, to kind of work behind the scenes. So this is instead of a normal setter. This is what makes the record class immutable behind the scenes. This property is not changeable. It's not modifiable at all. These ones are. That's kind of how it's all set up here. Oh my gosh. Okay. All right. Redundant explicit positional property declaration. Yeah, you say that. Then you didn't. Oh. Oh, hell. I know what I did wrong. Okay, guess I never needed any of that. I thought so. Update user. Let's see, where's update the user method here? Ah, I made that private. That's why. Okay. Okay, there we go. Info. Changed. Updated info. If info. Username. It's not equal. And if, let's say, let me go ahead and actually get rid of all that. Don't need it. And if, let's see, we got to go ahead and detect. I take a look at my start. Username equals info to username. Oh, boo. Well, I guess maybe I should make a version of this that doesn't use any nullable properties, but that'd be extra work. All right. Actually, I guess the easiest way to do this. Start username. See, possibility of a null reference. Let's see. Maybe that'd be okay. Start to username equals. Okay. If info to username is not equal null, and I guess I'll do this. And start not equal null. Actually, you know what I want? Let's see. I want to go ahead and check to see, okay, if the username, if this isn't null, but this is, I want to set this to that. However, I don't want to set them if they're both equal to the same thing. Let's see. And, well, why don't we do this? Username equals null. Or that. All right, that probably works. Okay. So in this case, I'll go ahead and do, all right, start equals start with, and I'll go ahead and say username equals info to username. All right, that'll go ahead and update the model here. And then I'll go ahead and add my updated properties. Updated username from, actually, I guess I could just do this. In fact, I should probably actually set this here before I modify it. Update username from start.username to info. Great. So this kind of gives us a little bit of an idea of what's actually changing behind the scenes here. I could probably, if I had a little bit more time, I could probably come up with a way to make this a little bit more concise. Off the top of my head, this is probably the way to do it. Okay, then if, let's see, info. The other thing I could probably do actually is add a merge function to the user info class itself that does all this behind the scenes. That way it wouldn't be the responsibility of the actor. That's something we could do for sure. That'd be another way of doing it. Change that. Updated email. There is a bit of boilerplate code in here. just in terms of how I'm doing this. I think it'll be okay. Email. And then let me go ahead and do another one for whatever our last property was. Let's see. Info. Email confirmed. Does not equal null. And start. Email confirmed equals null. Confirmated. Well, confirmed. Oh boy. There we go. All right, start email confirmed. All right. And I'll go ahead and do this. Okay, that should do it. Then I'll go ahead and basically say up here, we'll go ahead and return a little tuple, and I'll go ahead and include a new user changed event. And let's see, I'll go ahead and include, let's see. What do I need to include inside my user changed event? Oh, all that. Oh, I guess I don't need a tuple. Oh, yes, I do. Derp. My bad. New user changed event, and I need to include the original message. I'm going to go ahead and take a look and see if updated properties dot count is greater than 0. And then I'm going to go ahead and do string.join. Let's see. Actually, you know what? I'll do environment dot new line. And I'll go ahead and do updated properties. And then the other thing I need to include is I need to include start our updated model. All right, perfect. This should give me a nice sort of immutable model for being able to go ahead and process all these different possible changes that might happen. Whenever I want to go change the user's name, their email, whether it's confirmed, etc. All that stuff should be able to go ahead and just get processed through here. So I'm going to go ahead and do var user changed record. Let's see, new user equals diff user changed. I'm going to go ahead and pass in user info. We'll go ahead and do user update. Or did I get that backwards? Looks like I might have done that backwards. I don't know. That looks fine. Okay. And you know what else? Let me go ahead and add one of these. This class. Private read-only I logging adapter. Context. Get logger. That way we can print out a little bit of info about what's happening behind the scenes here. And I'll go ahead and do log info. Let's see. Okay, let me do this actually. If user changed record dot changed, if we didn't actually process any changes, meaning this event was somewhat of a no-op, I'm gonna go ahead and do log debug processed no-op change for user. And we'll go ahead and pass in the and you know what? I'll go ahead and use this as an opportunity to bail out right here. I'll go ahead and just call return. All right. Now, otherwise, I'm going to go ahead and call persist on my user changed event down here. Then I'm going to go ahead and have my little handler. I'm going to go ahead and do log info user changed record dot let's see, log changed. Then I'm going to go ahead and also say user info equals new user. I'm going to have to form a little bit of a closure over this, I guess, but that's not the end of it. All right. So that should allow me to go ahead and keep track of all these users' changes over time. Next, if I go ahead and get a command for, let's say, delete user. I'm going to go ahead and save this. I'm going to go ahead. You know what? I'm going to create one more special case in my protocol here. We have no user. I'll go ahead and say public. What the heck? Public static read only user info deleted user. All right. Special case for users who are deleted. All right, that should help. Okie dokie. Now if we go back in here, we will go ahead and call persist. Well, actually, I guess something we should do, go back to here, is nobody. This user. We should go ahead and do return user. Okay. One thing I should go ahead and check before I do diff user change is if user info is deleted, I can go ahead and just log an error. Attempted to update deleted user. Change not allowed. So I'm just going to go ahead and just return a negative on that. Let me take a look at our user store. Do I need to return an identity result? Okay, what does an identity result require? Identity errors. Okay. Failed. All right. Why should we go ahead and probably send one of these back to the sender every time we get one? So let me go ahead and do that, my identity actor here. All right. So we should go ahead and do sender new identity result. Oh God, is this mutable? Looks like it might be. I'd love to do that. Just pass in a set of success here. Okay, I guess I can do that. Identity result dot success. Okay, that's fair. So I'll go ahead and just return identity result. Type that out. Okay, that'll go ahead and give us sort of a successful acknowledgement back. And then we'll do the same down here. If this delete user call fails, we're going to go ahead and, you know what? Tell failed. New identity error. Code. And description. Well, I guess I may just go ahead and just format the string here. String format. So normally one of the things, by the way, I like to do with Akka.NET logging is I prefer to use the old-fashioned sort of, let's say you pass in the format string and then the arguments. In a really high traffic Akka.NET system, this means that all the string formatting happens in the logging actor and not your user actors. And the actual overhead of doing that formatting can be pretty significant in systems that are processing, let's say, hundreds of thousands of messages a second. So it's a bit of a micro performance optimization that most applications probably don't need to do. I kind of do it by default because it's a lot easier to just have it there from day one rather than needing to introduce it later because your application was running slow. So I tend to actually avoid this syntax for logging. But because I need to be able to pass this back in this identity error here, I'm going to go ahead and do it. To be honest, the identity system for draw together is not going to be a high traffic area of the application. So that's not going to be a big deal. All right, this delete user command. If a user is already deleted, we're just going to go ahead and process it again. We don't care about doing it a second time. So I'm going to go ahead and just handle this regardless. I'm going to go ahead and call persist. I'm going to go ahead and pass in, let's see, this delete command here. Go ahead and have a little bit of handling, and I'm going to do sender help. I'm just going to grab this. Okay, and I'm going to go ahead. All right. Oh, you know what else I need to do? User info equals deleted user. You knew. Did not mean to do that. There we go. Successfully deleted user. All right. The user is now deleted. We have now persisted that into our change history. And then if I have any commands for being able to go ahead and get information about this user, let's see, what did we add to the identity protocol here? We have a get user info and a get user by name command, which I'm going to go ahead and I got to add a little comment to that too. All right. Okay, so that should come in. So I'm going to go ahead and add a command here. Get user info. Go ahead and grab that. Now, if that got routed to me, then the user ID in here should match my user ID. So I don't necessarily need to validate that. I'll just go ahead and reply back. Actually, what does this stupid class expect? Let's see. Expects a DT anonymous user. Well, okay. I can go ahead and do that. You know what? Let me make this a little easier on you. I'm going to go ahead and do public static. Actually, you know what? I'll go ahead and do this in my protocol class instead. I'll go ahead and do another extension method. Static DT anonymous user from user info or to this user info. And we'll go ahead and do return new DT anonymous user ID equals user email. Yep. What else do we need? Username, I guess. Actually, that's something. Oh crap! Did I never add support to that? For this class? No, I did. Okay, thank goodness. All right. Okay. Let me go back to the identity protocol. Username equal. All right. That should do it. So I go here. I can just go ahead and do sender.tell user info. In fact, you know what? I'll take this one step further. Which is, let's see. All right. That's going to allocate every time I call it. That's not a big deal. I'll go ahead and pass that along. All right. Sender.tell user. That should be good. And I think that should do it for our identity actor on the persist side. Now, one thing I am going to need to go ahead and add. Is not real. Should be return user dot ID equals, let's see, identity protocol dot lead user or user.id. Actually, I should flip this around. Deleted users are going to be less common than non-existent users. So I should go ahead and do user ID dot equals protocol user ID. There we go. This will help us validate that this user isn't real if we get it served up. Okay. That's great. Okay. That should be a comma. All right, the identity actor is looking good on the right side. Now we got to add some read side events. And that's what these recover statements are for. And I'm going to go ahead and recover two different types. One is a update user command, or not update user, excuse me, user changed. And the other is going to go ahead and be a user change record's helpful. All right, I know what to do. So one's going to be the user change record. The other is going to go ahead and be this delete user command. Okay, so let's go ahead and do recover user changed event. And then, let's see, I guess I could, in theory, create a user changed event here. Okay, let's take a look at something. User info. Let's just go ahead and return a no op. Attempted to delete already deleted user. No need to necessarily propagate an error when this happens. It's already kind of kaput. And we'll just go ahead and call return. Otherwise, I'll go ahead and do var user changed event. And we'll go ahead and do delete through deleted user. We'll go ahead and do user ID. You know what else I might do? Add some timestamps to this. Let me go ahead and do that down here too. Yeah, why not? Okay, that looks good. All right. So now we only have one type of event we need to bring in, which is this user changed event. So what I'm going to go ahead and do is do a little switch statement on change dot, let's see, message case delete user. And what I'll go ahead and do here, so we're recovering our state from the database inside this code. I'm going to pour out the rest of my burp. We're actually recovering our state from the database inside this code here. Thank you, Noah's Mill. Rest in peace. We're recovering our state from the database, and so what I'm trying to do is rebuild this user info object in memory from the sum of the parts of before. So I want to change at some point in the future, whether it's possible to recreate deleted users. That's something I can actually go ahead and implement in here without having to go back in time and modify any of that data. So this allows us to go ahead and kind of change our domain models without needing to migrate schema or do anything else. That's one of the reasons why I'm such a big fan of this design pattern. So we delete the user. I'm going to go ahead and grab this little bit of code down here. User info equals deleted user. Now, otherwise, I'll do case user. So I think it's update user. Yeah. We'll go ahead and do down here. I'm gonna have to rediff everything. If user changed, user info, then I'm gonna need to go ahead and pass in the update command. And basically I'm gonna go ahead. I'm not gonna log anything this time. I'm just gonna say user info equals. Oh, in fact, you know what? Dirt. This needs to be like that. And basically, I need to just go ahead and grab the model. Great. This will allow me to go ahead and recover my in-memory state for each of these users. So I think that should do the trick there. So by the way Aqueduct Persistence works behind the scenes, before I can begin processing any of these commands, these are like messages that are sent by the live running application, I have to fully recover my state. In the event that this actor fails to recover its state, let's say because of a database timeout or something like that, this actor will actually kill itself and need to be recreated again, which will time out all of these requests behind the scenes here. So now that I have, now that I've gone through and I've scaffolded all that work inside that actor, in fact, let me go ahead and save this. Completed identity protocol and identity actor implementation. So let me go ahead and save that. What I'm trying to avoid, by the way, the reason why I want to use Aqueduct Persistence here is I want to make it so people can just clone and run this application without needing to run entity framework migrations and crap like that. That's what I'm really trying to do. Plus, I actually think the event sourcing model for this sort of thing is a lot more robust. Okay, so what I'm going to go ahead and do here is we're going to use the ask keyword to go ahead and implement some of these operations here. And I'm going to go ahead and create, let me go ahead and do using static identity protocol. I'm going to go ahead and let me do two windows again here. I want to go ahead and for this get user ID operation, I'm going to go ahead and send a get user info command. Let's see. So this assumes that we don't have the user's ID in here. That's delightful. So why don't we go ahead and assume, let's do this. Okay, get user ID async. If user dot, let's say ID equals null, or say does not equal null, then fine. We'll go ahead and return identity actor root dot ask DT anonymous user. Get user info, user.id. My guess is this will probably, yeah, there we go. And I think I need to call, let's see. I guess it wants me to await that. And I'll go ahead and serve that up. I guess I need an async declaration here. Do that. All right, that looks good. Okay, so now if this model does not have the user's identity, which it probably won't, let's go and check to see if the user name is available. User. Turn. Await. Identity root actor. And in theory, we can also support some other queries by looking up by the user's normalized name, or maybe we could use the email address to search up the user, all that fun stuff. And we want to search up the ID. All right, that's available. Now, for the time being, just to simplify things, if you don't have a username or an ID, we'll just go ahead and throw a not supported exception. Must have a user ID or username specified in the request. All right, go ahead and do that. That seems fair. Get username async. All right, let me go ahead and grab this. Stick that down there. And I want to return the, let's say, normalized username, I think. No, it needs to be, sorry, the regular username. Okay. And you know what? So I forgot to do this. Let's see. Well, I guess I don't need to override that. I can go ahead and do that in my identity protocol. All right, that should do that. Just pass in those normalized properties. That should be good. All right. Awaits. Gotta make an async declaration up there. I'll throw a not supported exception. That value is not supported. Set username async. Okay, now this is something we can work with. So, if the user ID is equal to null, we're going to go ahead and throw a new not supported exception. Copy this little error message here. Basically saying, hey, you know what? We can't set the name for a user who, you know, if we don't know what their identity is. So we're not doing that. But otherwise, we can go ahead and do return awaits. Let me go ahead and declare this as async right here. Let's see. Go ahead and do ask. Identity results. New update user. And then the updated info. New user info. We'll go ahead and do user ID. Then we'll go ahead and do username. And then next to that, do a cancellation token. I think that should be all right. Oh. Got it. All right. And what's this complaining about? Return type is void. Okay, well, guess I'll just do an await on that then. All right, get normalized username async. Okie dokie. Well, let me go ahead and get rid of our identity protocol. Don't think we need it anymore. Go down here. Try the normalized username. Oops. Wrong property. That was good. Okay. Set normalized username async. Okay. Right now we're treating those as the same property, but whatever. We can always split it back up later if we want. Make that async. Create user async. So here's what we're going to do here. We're going to throw a fit if the ID is null, which it shouldn't be. But in case it is, we will. That looks good. Update async. User ID must be specified. We'll go ahead and do user.username, user.email, user.email confirm. Sure. We'll go ahead and move that async as well. And I guess I need to return that there and there. Looking good so far. We'll go ahead and do this. Let's see. I need to go ahead and get rid of that. We'll make that asynchronous. We'll go ahead and do new user.id. All right, that looks good. All right, then at the very end down here, find by ID async. So I think we did. Yeah, we'll go ahead and just do this. All right. Make that async. That should be good. Then down in here, username. Okay, so then, sure. Okay, that's good. And I'll make that async. Okay, so we have now implemented our Akka user store. So I'll go ahead and add a little comment here. Okay, that looks good. We'll go ahead and say completed first user store implementation. One more thing we still need to do. Push that up. Which is I need to go ahead and create, I've got my identity actor. Is there a compilation error here? Take a look. Invalid option false. Must be disabled warnings or annotations. Okay, so I must have forked this. File system. Oh. Yeah, that would do it. All right, we'll do that Friday. Okay, so I'm just gonna semicolon there. Okay, looking good. Looks like I got some code. I need to go ahead and fix on here since I added the since I updated the new version of Akka.net where we made some changes to Akka.di, and we've also got some other warnings. That's okay. Go ahead and get this fixed. Push that up. And then we go back to looking at the solution. So one other actor I need to go ahead and add. We'll call this identity master. And this will go ahead and be receive actor. Parent actor. Keep track of all identity actors. Private read-only dictionary. String. Let's see. Users by name. Names by. Oh, this should be a string. Names by user. Well, I actually don't really need that, but that's okay. by the way, just to kind of explain one of the things I'm doing here, I like to go ahead and have these two different constructors. One that's this is what I'm actually going to use in practice. I like having this for unit testing, so I can go ahead and pre-populate some of the data that's inside this actor potentially. So I'm actually going to mark that as internal. Actually, I guess since this isn't a public application, internal doesn't really matter. I'll go ahead and leave that as is. Now, one thing I'm gonna need to do is I'm gonna need to go ahead and change these identity actors here. Yeah, let's see. I'm gonna need to have the ability to go ahead and track changes to an actor's identity potentially. So let me go ahead, private read only hash set. Let's see, identity index updates. And you know what? Identity index updates and subscribe. Here's what I'll go ahead and do. Every time a user successfully gets updated, tell. Yeah, here's what I'll do at the very end down here. Let's see. Actually, you know what? Let me check this out. The only thing we really care about is if the user's identity was set. Let's see. And we haven't actually updated these yet. Special case. Need to check if username was set or was changed. Okay. Let's see. You know what I just realized? One thing that we aren't doing quite right. No, actually we're doing this fine because the old property gets kept if I don't set it, so I don't need to worry about accidentally overriding something. Okay, that's fine. That's fine. We should be in good shape then. All right. These values aren't the same, then we should do this. Bool. Guess I could rename that property. Sub.tell. Guess I need to go ahead and just tell it. User info. All right, there we go. So our identity master actor right here, its job is basically to go ahead and maintain an index of all the different children with user identity. All right, and then we'll go ahead and do context.child. Let's see. Get or else. Oops. Go ahead and do this. Oh, it's not create. New identity actor. Self. All right. Var identity. This basically uses the create if not exist pattern to dynamically go ahead and look up this actor if it exists, and if it doesn't, we can dynamically create it on the fly. Then I'm going to go ahead and forward that actor this message. And now if I receive, let's see, identity protocol, with the username only. Username. I'm going to go ahead and check my little dictionary here. Oh, you know what else I got to do? I need to go ahead and do. I do one more thing. I need to go ahead and death watch this child actor. This lets me know when this actor shuts itself down or gets terminated. In fact, another thing I'm going to go ahead and do behind the scenes here is I'm going to go ahead, override, pre-start, context.set receive timeouts. If a user hasn't been active for longer than 20 minutes, then this actor will go ahead and shut itself down. Oops. Let's stop. Let's see. One other thing I should probably do is once we've finished completing recovery, we should also let our parent know what our user name is. So let me do that too. Let's see. On replay success. I'll go ahead and do this little bit of code here. Yep, that should work. Okay, there we go. That's perfect. Great, great, great. So what this should do, if I go ahead and do a receive user info, is if I'm receiving this data, presumably it's because someone's username was either changed or set for the first time. So what I should go ahead and do is say, okay, we're going to go ahead and all the old usernames will still be cached inside of here. That's one thing we don't really have settings for right now. I'd probably want to go ahead and use something like an index in a database to go ahead and resolve that, but that's all right for the time being. We're going to go ahead and do names by user, info, username. Oops. Sorry, that's the wrong construct. Users by name equals sender. The user's name is null. We should never have gotten this. We'll go ahead and do a little logging statement here. Context. Okay, logger. Now I'll go and say, all right. Log warning. Received user info event for user with a null user ID. Actually, you know what? One thing I can do to go ahead and check that. If I go down here, if user info, actually, let me do this. That should do the trick. That should make sure we never get a notification for that user's name being null in the event that that actor recovers. All right, that should be good. Else. Let's see, names by user. All right, Brant, thanks for the follow. I appreciate that. Let's see. Go ahead and do sender. Now, if I go ahead and I receive a death watch notification, so this is what happens as a byproduct of this context.watch call right here. This allows us to go ahead and receive a little notification back whenever one of these actors shuts down. I need to go ahead and garbage collect both of these dictionaries in the event that happens. So I'm going to go ahead and say, all right, if, let's see, names by user, contains key, then I'm going to go ahead and do our username equals names by user key.actorref. I'm going to do names by user remove. And I'm going to go ahead and remove, let's see. Key.actorref. Then I'll do users by name, remove username. There we go. That way we can go ahead and clean up our little collection there. That should help. That should help keep things clean. Now, if we come down here and I see this I with username only, I'm going to go ahead and do, all right, if users by name contains key and let's see, this should be username.username, then we should go ahead and do user by name dot forward new. Essentially, just go ahead and forward this request. And see, this actor's programmed to handle this, I believe. Get user. All right, that works. That should help. If not, we need to go ahead and do sender.tell. Let's see, we'll go ahead and do user info. Or user. There we go. That should do the trick. Okay. That should solve most of the problems from a actor system point of view. So if I go down to our services, Akka service, I'm going to go ahead and create in here a user manager. And this user manager will be system, actor of, project, identity master. Right? And then go ahead and call this identity. All right. That should put us in pretty good shape. That's all available. Let's see. You know what else I should probably actually do? Well, maybe that'll be okay. I have this iDraw session handler. Yeah, I think we should be all right. Because I kind of need to be able to pass this actor back and bind it via dependency injection for this whole thing to work. And that looks a little tricky at the moment. Why don't I do this? Go ahead and do that. I will take our Akka user store. Now we'll go ahead and rather than depending on this necessarily, I'll also have a private read-only service. DI magic. I'm going to go ahead and call this. Go ahead and create another constructor here. And I'll go ahead and say, for this implementation, that should do the trick. Let's see. You know what I can do? Let's see. So I try accessing that property before that service is started. That might create a little bit of a problem for me. Let me think. Yeah, there actually is an easy solution for this. Let me go ahead and do draw session handler. All right. Interface. What's this called? Identity actor service. Public actor ref. Oops, doing that wrong. That should be all right. That should be all right. All right, go ahead and grab that. Actually, let me move that into the file. Yeah, that should do some good. All right, go to Auth service. Get rid of that. Let's see, I can go ahead and set my identity actor here. And then I go ahead and take a dependency on this inside my little DI system. Let's see. Auth user store. I'm going to go ahead and turn this into a function. Go ahead and change this. All right, that should be good. Refactor that. Refactor that. Get rid of that. All right, voila. That should be a very DI-friendly way of doing all this stuff. All right, good. And so then if I go down to startup down here, I should go ahead and do, yeah, let's see. Services, add, let's see, transient. Actually, no, I can do singleton for all this. I can do singleton for this too. That shouldn't hurt anything. Oh no, wait a minute. Raw session handler. Let's go back in here. No, that should all be a singleton. All right. Let's see, identity service. You know what? I'm gonna go ahead and add my iHosted service first. Actually, crap. I guess I gotta do it this way. All right, that should be all right. I think that should be okay. Yeah, we'll see. Okay, don't need that. All right, now services.add identity. Let's see what I need to actually fulfill this. Add identity core. I don't know what the difference between these two is. Okay. All right, light me up. What do we need to do here? Oh, goodness. Let's see what the documentation says. We've built our user store class. We should be ready to go. Yeah. Add identity. Okay. All right. I guess this is kind of what I need. All right. See if this works. Get rid of that. Let's see. What's this thing grumbling about? It's a missing reference. Incorrect number of parameters. Apparently I need a role parameter. Okay. Well, that is something I can do. Let's see. DT anonymous user. We'll go ahead and call this Aki store. All right, so I need to go ahead and add a role type on that. Well, that's boring. Okay. So what do I need for that? A role store. Role information. All right. What if I did this? Tell you what, I'll make you a deal. Go ahead and go to DT anonymous user. DT anonymous role. Is there anything I need to do? Subclass here. Of course there is. Okay. What do you have implemented? Okay. All right. I suppose you could be wanting a role store now too. Okay. All right. Oh, goodness. Well. Aren't you in for a rough surprise here? Guess what? We're not implementing any of that. No role stores for you. All right. Actually, this honestly could also be singleton. All because Akka.net's active references don't require... There's nothing disposable about any of them. All right. That looks like progress to me. Anonymous roles and stores. Let me go ahead and check this in. Now, what I'm going to go ahead and try to do is have everybody who visits the homepage automatically be assigned a anonymous role. So I need to add a controller real fast. All right, controller, we'll go ahead and call this identity controller. Okay. Now, I want to go ahead and steal from Mr. Jason Watmore's little blog here. So he had a very helpful example of a little user controller here. Yeah, there we go. Controller, API controller. Go ahead and copy some of that. Let's see. All that good stuff. Okay, I should go ahead and grab my user service. Let's see. Private read only. User store. Yeah. We don't really care how it's implemented. We just care that we have it. Authenticate. Don't care about that. Register. Get all. Sure. You know what? These are things that we want. That's good. We should go ahead and grab some of that. Get by ID. Update. Update model. Delete. Okay. I'm a fan. We should at the very least do some of these. Let's go ahead and do this one first. Okay. Get rid of view. Okay. Register model. From body, register model. Law anonymous. Auto mapper, not using it. Not how we roll. Let's see, register model. Well, I'm assuming this is just a POCO class. Let's take a look. Users register model. Yeah, that's pretty easy. All right. So I'll go ahead and create my own little register model. Public. Yeah, that sounds good. We'll just stick with the user. Yeah, we'll stick with the username for now. Register model. All right. We'll go ahead and do user info. User info. And I guess I need to come up with a user ID, don't I? Well, I'll go ahead and do GUID. New GUID string for that. And then, you know what? More robust way of doing this. Let the model tell us. All right. That way this code's less opinionated. It's kind of keying off whatever the model does. Now, one thing I'm not checking for right now is uniqueness constraints inside our system. That's probably something I should be concerned about. User. Oh. Well. Touche. Okay. So I guess I need to do DT anonymous user. Well, that's no fun. Okay. Left operand is never null. My dear resharper or a writer, I do not believe you know JSON as well as I do. Sorry, not JSON. No, JSON as well as I do. That is definitely not how the world works there. All right. Create the user. Well, I want to see if the result actually came through. We shouldn't just return okay. Jeez. All right, non-user. In fact, you know what? I'm gonna make the ASP.NET gods thrilled, and I'm gonna go ahead and do this all asynchronously, the way it was meant to be done. All right. Non-user dot. Let's do an await here. Yeah, that's right. You all right? Okay. Well, that seems a little dangerous. Should probably just reply back with okay. I don't want to go ahead and expose the model when it's created. All the user's hashed passwords sitting around there. All right. User error. Add request. Yeah, sure. Okay. We'll go ahead and do new message. Okay. Let's equals. Yeah, sure. We'll go ahead and do this one. All right, that should be just dandy. And if we catch any type of exception down here, we'll go and return a bad request. All right, well, this looks like good progress so far. We're not quite done. We've got a little bit more work to do to get this web API up and running, but we've just built, in the course of the past couple hours here, an entire event source system for being able to go ahead and provide user identities. So that's fantastic. We're going to go ahead and actually try to take this thing for a test drive next Tuesday during our next stream. So, hey, I want to thank everyone tonight for attending. I always really enjoy doing these. I've always got a pretty full schedule of different programming things and training things. And in fact, I was signing a whole bunch of documents right before our stream started tonight. But I always really enjoy doing these. So thank you very much for your time tonight. I will look forward to seeing you all again next Tuesday. Until then, have a good weekend. And hope everyone has some fun coding Akadana out there. Thank you very much.